Thank you for joining me for this keynote. In this brief presentation, I'm going to introduce Lucid Motors and discuss how we use advanced simulation techniques to achieve a kind of measurable advantage for our vehicle products in the marketplace. I'll close out with a few thoughts on future directions too. I'm Wildig, the Vice President of Vehicle Engineering at Lucid Motors, based out of California. Vehicle engineering is a function which covers the engineering, design, and development of the vehicle object, if you like. Most every part that you see and touch. It doesn't include digital or high voltage content. In my team are also most of the attributes, including crash, NVH, aerodynamics, vehicle dynamics, durability, EMC, functional safety, and of course, all the related simulation to support those attributes. I've been at Lucid nearly 2 years, prior to which I had 3 decades of experience leading technical functions inside and outside of the scope of vehicle engineering. I am a subject matter expert in the field of design for crash safety, especially as it relates to high-performing premium vehicles. And beyond this, I spent my career jumping between very different engineering disciplines. And the only part of the vehicle I never touched is traditional engine design. In case you're wondering, there is a master key to all of these locks, and it's just engineering fundamentals. You know, everything we do is ultimately just engineering, right? I'm not a daily practitioner in simulation techniques, although I have worked with them extensively since the mid-1990s. On a personal note, I found it fascinating to see their capability grow and how they now play an increasingly essential role in our design workflow. Just in recent years, artificial intelligence has added a whole new dimension of capability and efficiency, and it makes it maybe the most exciting time I can remember to be involved in these tools. Here, my team at Lucid, we see simulation as a key area of growth and technical advantage. We've taken the leap to put simulation techniques actually at the heart of our concept definition process, and I'll talk more about that shortly. But let me first explain who Lucid is. Lucid is an electric vehicle manufacturer founded in 2016 and headquartered in Silicon Valley. We have a mission to advance the state of the art of EV technology for the benefit of all. And we do that by designing and building our own vehicles. We're a vertically integrated company, meaning we design, engineer, and manufacture our own unique technology. We have production plants in Arizona and the Kingdom of Saudi Arabia. And we have design centers in California, Michigan, Arizona, and actually half a dozen locations around the world. In 2021, we began production of the Lucid Air sedan. And last year, we began production of the Lucid Gravity SUV. Both are class-defining vehicles, and we're currently busy defining a new mid-size platform of more affordable vehicles. Through all this work, we developed unique in-house technologies and approaches in many areas of vehicle engineering and powertrain, and these make our vehicles world-beating in many measurable aspects. And you know, at Lucid, we have a growing group of carefully selected engineers who I think are some of the most talented in the automotive industry. We've encouraged them to challenge engineering paradigms and to find new ways of doing things, and they have the intelligence to take the initiative and follow through with that vision. So much of what I'll discuss shortly is actually innovation driven by the experts from the ground up. We have adopted tools and co-developed tools and also created tools to put simulation at the start of the process, to drive CAD with CAE and not the other way around. To compress optimization loops, to balance inputs across multiple attributes in parallel, to optimize early, already starting from the earliest studio services, and crucially to expand simulation into new engineering domains. And altogether, it amounts to a radically updated approach to vehicle concept design. The outcome is actually some of the most accomplished passenger vehicles in the world, the most efficient passenger vehicle in the world, the most powerful sedan in the world, the longest range EV in production, one of the fastest charging EVs in the world, and so on. You know, the Lucid Gravity requires half the battery size to achieve the range of its nearest competitor, and that means lighter mass and less impact on our precious planet. And this extreme efficiency also means that our future vehicles will have a price advantage because they need fewer batteries. On top of this, our space concept means the vehicles offer incredible space inside. Our vehicles have the occupant space of one vehicle class larger than their size on the road. Meanwhile, all of these vehicles are lauded for their ride and handling and NVH refinement. They're capable of achieving the highest levels of crash performance, including worldwide compliance and 5-star US NCAP crash test ratings. Let's have a look at a short video.
Imagine A car that goes as far as it does fast. As sleek as it is spacious. As smart as it is beautiful. Introducing Lucid Air. Experience the best.
These vehicles continue to receive awards and accolades. We think that the Lucid Air might be the most awarded American designed and built vehicle of all time. It won the Motor Trend Car of the Year first time out the gate, the only time a debut vehicle has achieved that accolade. And even now, more than 3 years after it went into production, it continues to win top industry recognition. So an interesting question is, why does Lucid have this advantage? It's not because we found a way around the physics. It's because the prevailing behavior in this company is first to challenge everything relentlessly using engineering fundamentals to find small gains, and then to take these small gains and multiply up their benefits across the vehicle, which is not typically done, at least not on the scale and breadth we do it here in Lucid. That's possible because there is an unusually deep technical understanding throughout Lucid leadership that allows us to think in this sort of multi-dimensional way for the benefit of the product across the vehicle rather than across the organization. But the topic at hand today is, how do we find these small engineering gains in the first place? We do so by deconstructing every problem to its quintessential elements, and that's where simulation comes in, and where Altair tools, amongst others, are crucial weapons in our armory. I think it's fair to say that Lucid are amongst the most advanced, if not the most advanced user of Altair tools in automotive. We are often first adopters on new tools and modules. We collaborate directly with the developers to tune early code. We've built a design workflow with an extensive use of Altair tools, and we even create our own proprietary tools off the back of Altair output. So I'm going to take a moment to discuss how we use some of these Altair tools to create an advantage. And this will go into a little bit of detail, but stick with me and we'll get to the broader themes and directions towards the end, especially related to AI. So starting with concept morphing. Hypermorph is a tool which allows Lucid to take existing full vehicle models for NVH and crash and warp them to fit a studio design surface for a different format product, such as from, say, a sedan to an SUV. And this means that before we've drawn lines in CAD, we're already getting a sense of the constraints and opportunities of the new form factor. And this in turn drives the first CAD generation. So it is CAE driving CAD. We use morph volume and freehand morph techniques and sometimes seed models from the public domain to match the intended dimensions and form factor of the new vehicle. And the goal here is not detail, it's not precision and fidelity, but rather a foundational understanding of the engineering fundamentals in order to guide the design studio, the product decisions and the CAD geometry generation as early as possible. And this gives us a huge advantage in eliminating compromise because it starts us already in the right ballpark. To build on this, we also get into topology optimization immediately at Lucid, and we're running topology optimization all the way through to design sign-off. At first, we're adding voxel topology blocks and then using OptiStruct to identify areas of the baseline vehicle that have the most opportunities for improving stiffness with minimum mass. And we also assess specific parts of the body structure in isolation, which allows us to have a quicker and more refined loop. Our design engineers then take that output and interpret it to produce manufacturing feasible CAD. Optimization algorithms are so much more powerful than the human trial and error loops that were based on visual interpretations of strain energy density plots. Both strive to do the same thing, but humans just can't beat the computer algorithms. And so what used to take us weeks to root cause can be done in a day, and it gives us a head start on achieving that least compromised solution. And we use topology optimization for crash too, which is unusual. Optimization technologies have been around for many years, and although they've been successful in solving complex NVH and durability requirements, they've been less successful in the field of crash analysis. And the reason is that crash analysis typically requires nonlinear, explicit, so time-based solvers. And there are tools on the market that do optimize for crash, but loops of analysis typically take too long to be practical. Genesis is relatively lightweight. We started with a non-linear crash simulation, and then we used the displacement field for separate linear optimization models. Linear models are much faster. So after a quick couple of loops, we go back and confirm with a longer non-linear analysis, and so we repeat until we converge on meeting the crash requirement. Up until this point, topology optimization has been successfully used to optimize the mass and performance of backup structures, but now we're seeing meaningful savings in mass and geometry improvements using Genesis for crushable structures too. Added to all these things, we also combine results across disciplines. For almost 2 decades in the industry, we've seen numerous efforts to optimize multiple vehicle attribute domains simultaneously in the design process, but we have been constrained by computational power and limited algorithms, and it's just not been practical. Now, finally, we're seeing a practical implementation with the use of MDO Director combined with HyperStudy. This kind of multidisciplinary or multi-domain approach synchronizes simulation across different attributes like crash and NVH, and also synchronizes across different solvers. MDO approaches this by looking for common factors across simulation outputs and then uses them as design variables in future optimization loops. There's a lot more to it, but this is the wrong presentation for that level of detail. Suffice to say, we've seen significant savings in mass reduction using this tool, and in fact, there are several more ways that we're embedding this multi-domain approach into our design workflow now. We also use Altair tools like 𝗖𝗧 and 𝗪𝗧 during CAD generation. The theme here is that a kind of democratization of simulation tools, right? The design engineers in my team are able to perform quick analyses of the full vehicle body structure models and get stiffness and modal results within a couple of hours using a meshless solver called 𝗪𝗧. This approach is becoming increasingly common in product design teams, so that's not unusual, but our vision at Lucid goes further. The design engineer only needs to apply tags to the geometry, then export it, and then we use custom written scripts in Altair 𝗪𝗧 to convert the tags to be usable in 𝗪𝗧 solver. On a broader note, exploiting engineering fundamentals is the role of every design engineer at Lucid, and not just those with access to unusual or bespoke or cutting-edge optimization tools. That's the reason for using 𝗪𝗧 in this case. I want to talk a bit about AI and how we currently use it in simulation. Altair Physics AI is a kind of GDL, geometric deep learning tool, which operates directly on the finite element meshes and CAD models. The goal of the tools is to use past simulation results to kind of predict future simulation outcomes, you could say, with the idea that you don't need to run a lengthy simulation to get an instant prediction. And what's different about Physics AI from conventional response surface tools we use is that it's non-parametric, meaning that the user doesn't have to define which variables a simulation should train for. So at Lucid, we've been trialing Physics AI with compute-intensive load cases like pedestrian protection hood impact, and the results are good and getting better, but in my judgment at least, they're not a substitute for replacing domain expertise on complex problems, right? We are going to continue to work with this tool to help us development, and we think it'll show net benefits pretty soon. Another AI tool that promises productivity improvements is Altair RapidMiner. At Lucid, we currently material test thousands of joint coupons in-house for different stack-up thicknesses, different material types, different material grades, different joint connection types, and so on. And each time that we have a variation in joint design, we now use RapidMiner to tell us whether a new test is required. The obvious benefit here is time and effort saved. And beyond these Altair tools and tools from other companies, we also build our own tools off their output. For example, we've written a connection tool which assesses which spot welds, self-piercing rivets, flow drill screws are effective across combined crash durability, NVH load cases. And then we add layers of sophistication in filtering for cost, robot parameters, loads, failure mode, and so on. And this allows us to confidently and accurately eliminate unnecessary connection points in the vehicle design. And there are other examples beside these. So altogether, that was a brief tour of how we're using Altair tools, amongst others, to create a bespoke simulation-led design process in Lucid that optimizes across domain specialties with the aim of accelerating the development process and finding new optima. Where we're seeing the benefits of these tools, it's not necessarily in more accurate absolute predictions, but rather it's the speed and the ability to find a better ultimate solution. Speed because we're early enough to drive early concept decisions, and our CAE loops are compressed enough to drive CAD rather than the other way around. And less compromise because we can factor in multiple attributes simultaneously, which brings us to a new level of optimization. I'm going to close out with some thoughts about our direction of travel and where artificial intelligence fits in. So artificial intelligence is unlocking all sorts of capability for us in Lucid, in tools we're experimenting with and developing ourselves, whether through extracting a better understanding of consumers in the marketplace, whether by supporting our own customers in the vehicle ownership journey, whether by improving the vehicle itself with AI features, or in this case, by using AI to make the development process faster and create less compromised vehicles. But progress in these tools is not linear with time. It comes in fits and starts. And right now I see fertile ground for these kind of techniques with advancements in machine learning, for example. And yet with machine learning, I also see a fundamental constraint with training set size, even using simulation data from physics-based models. And that's ultimately going to put a limit on the accuracy of these results, Maybe we'll conquer these constraints on training set size with new AI techniques beyond deep learning and machine learning. Or maybe we'll make a breakthrough in a hybrid approach of model and database methods. Or maybe the raw power of quantum computing will take traditional deterministic analysis methods and make them relevant again by making them practical and fast enough to meet our shorter and shorter program timelines. I'm really curious to see how it works out, and I want my team to be at the center of new developments. In the meantime, I have a few thoughts, some advice, if you'll allow me. AI-driven tools are powerful, but you should avoid being misled by the output. In technical parlance, their performance is fractal or jagged, right? The current generation of AI tools can confidently tell you the wrong answer, and they can hallucinate too. So if you want to qualify an engineering result from an AI tool, then it's actually more vital than ever before that your team has a strong commanding of engineering fundamentals, if only for a plausibility checksum, right? Human in the loop is still vital until we can build real reasoning tools that use reinforcement learning to train human feedback into models, right? Secondly, in my team, we found great benefit in working directly with developers, in this case, Altair. When we're testing new tools, we're not thinking of ourselves as simply customers. We think of ourselves as co-developers. Since we're the ones using the tools, we can give the real-world feedback, and we can also share ideas about what problems we still want to solve together. And as an added bonus, my team are now sufficiently educated in these tools that they create their own in-house apps and methods off the back of these industry-wide tools. So whether you're a developer or a practitioner, I recommend that you reach out and collaborate with one another. Thirdly, don't simply get lost in following improvements in this existing set of AI tools. It's like perfecting the steam engine. It's beautiful, but of its time, and it quickly could become obsolete. What I mean by that is the next tool to come along could render your efforts irrelevant. So I recommend that you find ways to stay at the forefront of developments, and conferences like these are certainly one way. My advice is to seek out the likely sources of future ideas rather than try and follow the current hype. So for example, when I was a researcher at college many decades ago, I used to read the chemistry papers to learn what was going to be the next big thing in engineering materials. The next approach, the next form of AI will be a mindset shift, and it will probably be triggered by some advancement outside of your core field of knowledge, so be ready. Finally, and crucially, don't focus on the solutions, focus on the problems. When you're looking for opportunities and new ways of doing things, don't just go shopping for the latest fad in tools and try and find ways you should be using them. If you're an engineer, you should be defining your world with the problems you're trying to solve and then applying solutions where appropriate. Most of us listening to this talk are engineers or running engineering teams. We exist to solve the world challenges. That's what motivates us, at least that's what motivates me. I have a head full of the problems that I wish I could solve, and just because a problem is too difficult to solve right now, I don't give up and look elsewhere. I double down. I think about which part of the industry or research facility that solution is likely to come from, and I find ways to get connected, to get involved. I think about how the world will change for my team when a solution suddenly appears to that problem, and I get ready for when that happens. To put it more simply, if you can't define your problems accurately, then you're less likely to find solutions for them. So I'm going to close out and say that no matter how you choose to approach these new techniques and how you keep on top of the technology, one thing is for sure. In the automotive industry, we have to keep finding ways to drive lower costs and shorter timelines, and also lower mass and less impact on our planet. And at Lucid, we want to drive better products too, and that means driving out compromise. Here at Lucid, one way we do this is to stay at the forefront of engineering methodology, and tools like this from Altair are at the heart of those efforts. Thank you for listening.